Bismillahirrahmanirrahim. Assalamu alaikum. In this video, we shall find volume of solid of revolution. Let us know what is a solid of revolution. We draw the graph of some function f of x. Let us say this is the graph of some function f of x, which is from x is equal to a to x is equal to b. Now, if we rotate this region about the x-axis, as a result, we get some solid thing like this one, and that thing is called solid of revolution. Now let us draw the graph of another function. This is y-axis, this one is x-axis. Let us say the graph of some function is like this one. This is a function g of y, which is from y is equal to c to y is equal to d. Now, if we rotate this graph about the y-axis, as a result, we get some solid thing like this one. And that thing is called solid of revolution. Let us draw the graph of another function. So the graph of the function, let us say, is like this one. This is some function f of x. Now, if we rotate this region, let us say it is from x is equal to a to x is equal to b, about the x-axis. As a result, again, we get some solid thing like this one, and that thing is called solid of revolution. So in this lecture, we shall study different methods to find volumes of such type of solids. The first method which is used to find volume of solid of revolution is called the disk method. In this method, we divide the whole solid into small disks, and then we find volume of each disk. So let us consider the only one disk which you can see here. Then that is the thickness of this disk. We denote this by delta x, and that is the radius of this disk. So to find volume of this disk, we write volume V1 is equal to area 1, area is of that disk, into thickness. So area is pi r square, so we write pi r1 square delta x. Similarly, we can find another disk and we can find its volume V2. So V2 is equal to pi r2 square delta x. Similarly, we can find another disk and find its volume V3, which will be equal to pi r3 square delta x. And in a similar procedure, we can find volume of the nth disk, Vn. Vn is equal to pi rn square delta x. And now we add all these volumes. So we have V is equal to V1 plus V2 plus up to Vn. Putting the values, we get this thing. And now taking limits n approaches to infinity, we get the required volume of the whole solid of revolution, which is equal to pi a to b r of x square dx. So the method of proof is very similar to that of the Riemann sum. And now look at the first one. if we are given that the axis of rotation is x-axis, and there will be given function f of x which will be defined on the interval a comma b, then we shall use formula number 1 to find volume of that solid. Here r of x is equal to f of x which will be given in the question. Now if axis of rotation is y-axis and we are given a function f of y with some interval, then we shall use formula number 2 to find volume of that solid of revolution. And here again r of y will be equal to the given function f of y. In example number 1, we are given a function y is equal to x square, and we rotate it about the x-axis to generate a solid. Now to find its volume, we use formula number 1, which is given by v is equal to pi, integration is from a to b r of x square into dx. Now in this formula, here we have r of x which is equal to y. Y is f of x, and that is x square. And the limits are a is 0 and b is 1. So putting these values in formula number 1, we have v is equal to pi, integration is from 0 to 1, r of x is x square whole square into dx. To solve this problem, we can write it like x square of square. So this is x power 4 dx. And now we need just to integrate it. So its integration is x5 divided by 5. The limits are from 0 to 1. And now if we use the limits, we get pi by 5. So that is the required solution of this problem. Now let us see the graph of this function. The graph of this function is like this one, which is from origin 0 to a point x is equal to 1. And now you can see if I rotate this about the x-axis, we can get a figure like this one. So this is now a solid of revolution, and actually we need to find its volume. Now this is r of x, it is the radius, and this is the curve y is equal to x square. Now look at example number 2. Again we are given the same function y is equal to x square, but we rotate it about the y-axis, and the limits are also same, which are from 0 to 1. So we need to find volume of the solid. Now from this function we need a function of y instead of x. So taking square root of both sides, we have x is equal to y under the root. And as the limits are from 0 to 1, it means it is above the x-axis. So now here, this is the function f of y, which is equal to under root y. Now if x is 0, then let us say this is equation number 2. Then from 2 putting x is equal to 0, look at here, this is x is equal to y under the root. So putting x 0, we get y is equal to 0. And if we put x is equal to 1, we get y is equal to 1. So the limits of y can be written as from 0 to 1. And now to find its volume, we use formula number 2, which is given by pi c to d r of y whole square dy. In this case, r of y is under root y. So let us put its value. We have pi, integration is from 0 to 1 and under root y whole square dy. If we simplify this, we get 0 to 1 y dy. Let us integrate it. So if we integrate it, we get pi and y square by 2, where the limits are from 0 to 1. So if we put the limits, we get pi by 2. And that is the required solution of this problem. Now, look at the graph once again. Here we have the same function. Look at here, this is the function, which is x is equal to under root y. And now we are rotating it about the y-axis. This is the y-axis. So let us say this is 0.1, this is 0. So if we rotate it, we get a figure like this one. And now here, this thing, this from the origin to here, we take it r of y. This is the radius. And we can see that finding the volume of this solid, we get v is equal to pi by 2. In example number 3, we are given an equation of a circle and we are rotating it about the x-axis to form a sphere. To find its volume, we use formula number 1, which is given by pi, integration is from a to b r of x whole square into dx. Now, for this formula, we need r of x, which is a function of x. So, from the equation of circle, x square plus y square is equal to r square. We get the value of y square, which is equal to r square minus x square. And if we take square root, we get y is equal to r square minus x square under the root. So now the next thing which we need are the points A and B. So the circle, when the circle touches the x-axis, here y must be 0 on the x-axis. So putting y is equal to 0 in equation number 2, we get r square minus x square under the root is equal to 0. And from here we get x is equal to plus minus r. So the value of a is now minus r and the value of b is r. And here f of x, this is r square minus x square, which is the required radius r of x. So putting these values in equation number 1, formula number 1, we have y is equal to pi. Integration is from minus r to r. The value of r of x, which is r square minus x square under the root whole square into dx. And if we simplify this, we get y is equal to pi. Integration is from minus r to r square minus x square dx. Here r is radius and it is a constant. So just integrating, we get pi into r square x minus x cube by 3. Limits are from minus r to r. And now let us put these limits. So we have pi into, putting r, we have r cube minus r cube by 3 minus into minus r cube minus, and this will become plus r cube by 3. And if we further simplify this, we get 2 pi into r cube minus r cube by 3. And let us take LCM. So we have 2 pi. The LCM is 3. So we have 2r cube minus r cube. And from this, after simplification, we get 4 by 3 pi r cube, which is volume of a sphere. In example number 4, we are given a curve y is equal to under root x and another curve y is equal to 1, which is a straight line. And we need to rotate the region between these two curves about the line y is equal to 1 to generate a solid. And then we need its volume. One point on the x-axis is given, which is x is equal to 4. And now to find another point, we find point of intersection of these two curves. Another word, this is f of x and this is g of x. We put f of x is equal to g of x to find the value of x. So we have under root x is equal to 1. And from here we get 1 point, x is equal to 1. So now we have 2 points. One is 1, the other is 4. So we need to check which curve is greater in this interval. So the first curve is under root x and the other is y is equal to 1. So if we put different values from this interval, we can see that under root x is greater than or equal to 1. So in this case, we will find r of x, which will be equal to the bigger curve minus the smaller curve. And now volume is obtained as using formula number 1. Integration is from a to b r of x whole square into dx. Putting values, we have pi. Integration is from 1 to 4. R of x is under root x minus 1 into dx. Let us simplify this. So we have integration is from 1 to 4. Under root x square is x minus 2 under root x plus 1 square is 1 into dx. Let us integrate this. So we have x square divided by 2 minus 2 x power 1 over 2 plus 1, which is 3 by 2, divided by 3 by 2 plus x, and the limits are from 1 to 4. Now if we put these limits, we get the solution, which is 7 pi by 6. So that is the required solution or volume of the region rotated by these two curves about the line y is equal to 1. let us see the graph of this question. So this is 1 on y-axis. From 1 we draw a line which is parallel to x-axis, and that is the line y is equal to 1. Now on x-axis this is 1. So our curve starts from 1, let us say this is 1, and it goes up to 4. So the graph of the curve is like this one. This is the graph of the curve y is equal to under root x. And we have to rotate this whole region about the line y is equal to 1, not about the x-axis. So first of all, look at the radius, which is a distance from the x-axis. That is, the distance from the x-axis is y is equal to under root x, and distance of y is equal to 1 from the x-axis. That is, y is equal to 1, but we need the radius, which is this one. This is the required radius. To find this radius, if we subtract 1 from under root x, in other words, you can see this is under root x and this is 1. So if we subtract this region from the whole, this portion will remove and we can get the required radius, which is under root x minus 1. Now if I rotate this curve about the line is equal to line y is equal to 1, we get a curve like this one, and we find a solid of revolution. So that is the solid of revolution, and its volume is 7 pi by 6.